two topics. One is real world examples. Where might we want to use rational functions? And then solving rational equations. So example 1 says, Adam's mobile phone has a limited amount of free space which he can use to, that's supposed to be to, store photos. Adam's photo has 240 megabytes of storage space. The phone settings allow Adam to choose the default photo size in megabytes. The photo size is the amount of storage space that each photo occupies on the phone. So it says, complete the table which shows the default photo size and the number of photos that Adam can store on his phone. So 120 photos takes up 2 megabytes. And 40 photos use up 6 megabytes. So I want you to stop and think here a moment. What pattern do you see in just those 2 columns to sort of help figure it out? Because it's not 60, like you can't just divide and say 60 because that doesn't work at the 6. Is there something else? Yeah, Noe?
240 divided by the photo size.
Okay, so do you see the 240 divided by the photo size? 240 divided by the photo size, so what would it be for 3 then? 80. Okay, how about for 4? 60. How about for 5? You might need a calculator. 48. All right, how about for 8? 30, 10, 24, 20, and 8. So what we're getting is y equals 240 divided by x. Now anytime you see GDC, that stands for graphing calculator. Okay, GDC stands for graphing calculator. It says you can use a graphing calculator. I don't think we really need one, but let's give it a whirl. So if I'm going to go 5, 10, 15, 20, 25, 30. Whoops, sorry, I put that in the wrong thing, didn't I? I did the wrong axes, hold on. I'm gonna try that again, because X is the photo size, and Y is the number of photos, so I put the wrong. Or no, I had that right, didn't I? Silly. Then so then for 2, you're going to just eyeball where 2 is. 5 is 48, 10 was 24, and 30 was 8. So this is the graph of y equals 240 over x. Can x be negative? Can you have a negative photo size? No. So let's talk about domain, and you can't have 0 either, so I would say that my domain is x is greater than 0. Then it says Adam wants to have space to store 50 photos. Use a graphical approach to find the maximum individual photo size. So what that means graphically is you're looking for the intersection. So what you would do is if you have your graphing calculator, I would take it out and you would graph y1 is 240 over x, and in the second graph, and then find the intersection. So do you have graphing calculators? All right, anybody find it yet? If you have your graphing calculators, graph y equals 240 divided by x, and then y equals 50 on the same grid, and then you can press menu, calc, and something about intersection there. I got about 4.8 megabytes. Then algebraically, you would take 50 equals 240 over x, and then I'm just gonna make that a,
We can't see the screen.
oops, I lost it. Okay. 6795. Thank you. So I would set 50 equals 240 over x, then create a proportion. A proportion is when you have one fraction equals one fraction. So I'm going to get 50x equals 240, and I still get about 4.8 megabytes. All right, questions on that one? All right, so being able to use rational expressions and rational equations to solve real-world problems is one of our topics. Then the second topic is solving rational equations. I know we do this in Algebra 2, so let's just do a brief refresher. So when you want to solve a rational equation, factor each denominator, state the domain, determine the LCD, multiply both sides of the equation by the LCD in order to clear the fractions. Solve the resulting equation. Check the domain at the end. So we're gonna do 2 examples here, and we're gonna go through the 6 steps both times. And then you have these in your notes to use to help yourself. So step 1 is factor each denominator. In example 2, there's no factoring. Okay, check. Step 2, state the domain. Well, what are the values that would make me divide by 0?
0 and -1.
0 and -1. Step 3, determine the LCD. Now this -2 on the right is over 1. So the LCD is 2x times x plus 1. It's usually your factors that you have factored. If you have any factors that repeat, you don't write them twice. So if I had an x minus 3 in one denominator, x minus 3, I only need it once, okay? All right, step 4 says multiply both sides of the equation by the LCD. Now it is going to get distributed here. So I'm going to write it out the first time, and then I'm going to try to do it mentally, because it's just a pain to write it all out. So what I've done is I'm in step 4, and I'm multiplying both sides of the equation by the LCD in order to clear the fractions. So watch what's going to happen. The 2x cancels, and I'm left with 3 times x plus 1. I have a subtraction sign. The x plus 1's cancel, and I have 2x times 2x. On the right side, nothing canceled. So I'm going to multiply the first 2 and make it negative 4x times x plus 1. Step 5 says solve the resulting equation. So I'm going to pause a moment and give you a good minute or 2 head start on me. And I want you to solve it, then check the domain, make sure your answer is allowable. I'll tell you the answer is a fraction, and it's okay to get a fraction. All right, if you've done it correctly, you should get negative 3/7. Okay, let's work it out. I get 3x plus 3 minus 4x squared equals minus 4x squared minus 4x. If you add 4x squared to both sides, they cancel. I'm going to subtract 3x and get 3 equals negative 7x. Divide by negative 7, x is negative 3/7. I check it against my domain. It says x cannot be 0 or negative 1, so negative 3/7 is okay. All right, what questions do you have that I can clarify for you? All right, then let's try this next one. There's no factoring. My domain, x cannot be negative 8 or negative 1. The LCD is x plus 8 times x plus 1. All right, so I'm going to multiply by the LCD. Be careful. For some reason, every year I teach rational equations, I have a student who does not want to multiply this number 1 because they're like, there's no fraction, so I'm not going to multiply it. Well, we have what's called the multiplication property of equations that says I can multiply the left side and the right side. I don't have any math property that says I'm going to multiply 2 out of the 3 things. So that's not true. So I'm going to cross out the x plus 8s, and I get x plus 1 times x plus 5. Here, the 1 times just gives me x squared plus 9x plus 8. The x plus 1 cancels, and I get 6 times x plus 8. I'm going to pause a moment and let you work that. It works out really nicely where the x squareds cancel again. I'm getting, whoops, sorry, negative 17 thirds. Yuck. Yuck, but true. All right, any questions on that one?